In this video recording, we're going to demonstrate how to manipulate RTK survey data from a variety of different sources into a composite and unified coordinate file structure for use in a highway planning and redesign project. To start off with, I want to take a quick look at the project site area. In this case, I've got a Google Earth place mark area showing a work area that's located along US Highway 52 in northern Iowa. And what I've done then is I've taken this polygon boundary that's on the screen here right now and imported it into my Carlson software running here in the background. So we'll go ahead and take a look at that, and what I have then is this polygon boundary that's been drawn in relative to a drawing setup that has been established with Iowa Regional Coordinate System Zone number 2 for Mason City. And with these regional coordinates then, what I want to do is take RTK GPS data, again gathered with 5 different crews back in May of 2015, and get that manipulated into the Iowa Regional Coordinate System Zone. So to start with, what I'll do then is take a look at the raw data. So I'm going to go and switch into my Carlson survey menus by going into Settings, and then Carlson menus, and we'll go into Survey menu. And what I want to do then is look at the underlying raw data files. So to start with, I'm going to go to my Survey menu. I'll choose Edit Process Raw Data. And what we want to do then is actually bring in the data. So first off, I've got no raw files established, and a coordinate file that was established previously for me, which was a Highway 52 LiDAR coordinate file. So what I want to do is actually make a brand new coordinate file. So I'm going to say New CRD file, and I'll call this Highway 52 GPS, to keep my GPS data separate from my LiDAR data. And what I want to do then is go into my file menu, and I'll start to do some imports then. So I'm going to import the first file that I have in here, which is a Carlson formatted file, and you can see that I've got, again, these different RW5 files, and these came out of, in this case, Carlson Serve PC, and this one was defined actually originally in the Mason County City Zone, so I'm going to go ahead and just choose Open on that. We'll go ahead and open up another one, and in this case I want to open again another Carlson one, and this will be the State Line Centerline Demo raw file, and we'll go ahead and open that one up. We'll also go ahead and then import another one, which was the Highway 52 raw file. We'll import another one, which is also a Carlson format called Training. And this one we can see here was collected again with Carlson Serve CE, but in a UTM Zone 15 coordinate system. We'll import another one. This is also a Carlson formatted Train RW5, and this one was also collected in UTM WGS 84 Zone 15. And then we have one more, which is actually a TDS based raw file. So I'm going to go to File and Import, and we'll say let's go and grab the TDS file, and that one was actually called State Line Road, and it's an RAW file. And as I look at the RAW file in here, one of the things that came out to us was, again, that this was actually stored in Iowa North coordinates. So a lot of the points that were actually recorded in this file were actually stored point coordinate values. So what we want to do then is we're going to convert all of the Carlson formatted files into Iowa North. So we're going to go ahead and open this up. So to process all these raw files, I'm going to go to Process Compute Points. And the first one I'm going to do is just a no adjust, and that'll handle the TDS raw file. So I'm going to say for multiple measurements at the same point, just go ahead and use the first instance, and the rest of this information I'll just go ahead and say is okay. And actually what we've got then is a conflict where multiple store points records point to the same point number. So I'm just going to go ahead and say continue processing for right now. And I have my initial report, and I'm going to go ahead and exit out of that report. And what I also want to do now is do a process compute points, and this time we're going to say, let's go and take a look at all the GPS readings. So when I run this, again, we're going to process all of this data into state plane 83 for Iowa North, and if we have any kind of geoid elevations to apply, in this case we'll use the geoid 2012B format, and I'll just go ahead and choose OK. And we'll process all those measurements then and develop then the Iowa North coordinates for all these data shots that were collected again back in May of 2015. So with this data now established, I'm going to go ahead and close out of my report, and we'll do a file exit. It's asking me if I want to save my raw file. In this case I'll say no, but I do want to save my coordinate file changes, yes. So with my coordinate file, what I'm going to do now is set that coordinate file as active. So I'm going to go to my points menu, say set coordinate file, and I want to go grab now my Highway 52 GPS, and we'll open it up. And we'll take a look at some of the data in here, and again I'm going to go into my points menu and I'll say list points, and I'll just choose all points that are in here. We'll just go ahead and choose OK. And again, what we have now are Iowa North coordinate values, also maybe some base station location coordinates in here, but you can see we've got a massive amount of data, and the survey crews that were out gathering this data collected the data using their own feature codes with their own coding conventions, their own equipment. So again, we have a lot of different sources of information in here that we can then make use of. So now that I have my data in Iowa North, what I really want to do is get my data relative to the Iowa Regional Coordinate System Zone number 2 that I had it again established and discussed inside of my drawing setup. So I want to make my data relative to this coordinate system. To do that, I'm going to go to my points menu. I'm going to say adjust coordinates, and I'm going to do a coordinate transformation. I am going to go from grid to grid by point numbers. I'm going to overwrite all of the Iowa North coordinates with the Iowa Regional Coordinate System Zones coordinates. We'll just choose OK. And in this case, I've got some my favorites established. I have my Iowa North in US feet going to the Iowa Regional Coordinate System Zone number 2 in US feet. And to get these values in here, I chose the more predefined user-defined option, and then clicked the set option to go and say and add predefined the coordinate system zones that I'm interested in getting. In this case, again, I chose Iowa North out of my main list in here. And then I also was able to go out and grab for my US Iowa counties the individual regional coordinate system zones that I'm interested in. So with these values set, I'm going to go ahead and just choose OK. And we're going to process all of my points. And now that coordinate transformation has taken place. And now what I would like to do is to go ahead and put this data onto my screen, but within the limits of this project site area that I have drawn. So I'm going to go to my survey menu, and I'm going to say draw field to finish. And I'll worry about the split multiple codes here later on, so say split no multiple codes. And again, I have all my data, and in this case I'm going to say draw within a polyline boundary. And I have then a code table that's been established, which was the codes from the feature codes themselves. And as I'm taking a look at all the different codes, again, these were all the different codes that the surveyors had used. And one of the things that I'm going to do actually is to take and make sure that the ground shots, things that do not belong to the road, are actually not processed. So I'm going to say for my GND shots, don't process those. For my ground shot code, don't process those. And then anything else in here that I have, toes of slopes, tops of banks, shoulder non-paved, that kind of stuff, everything else in here I'm sure is going to be okay. Actually, maybe for my driveway shots, maybe I won't actually process those, because again, all I'm interested in this case is just the US Highway 52 itself. So I'm going to go ahead and just choose OK. And with these changes made then, I'm going to go ahead and say exit. Save my changes, sure. And we will go ahead and process all the data. So I'm just going to say OK. And then the close polyline from the data that I'm supposed to use in here, I'll just click on this polygon boundary. and then we'll go through and then process all those data again now into our original coordinate system zones. So if we take a look at the data in here now, you can see that we actually have all the shots in here for center lines, edge of pavements, and shoulder locations, and what we can do then is take and use this information as the basis for a surface model to follow. So what we're going to do now is to go ahead, and I'm going to freeze the limits of my data in here. So I'll go ahead and do a view, and I'll freeze layer by pick, and I'll grab that option out of there. And what I want to do now is put a perimeter boundary around all this data. So I'm going to go ahead and say for my draw menu, I'm going to say shrink wrap entities. And I'm going to put this onto a layer called maybe v-topo-bndy for a topo boundary, for example. And I'll say across gaps. And we'll make this a 2D polyline is fine. And actually, let's make this a relatively tightly fitting boundary polyline through a high perimeter reduction value. So I'm going to go ahead and choose OK. We'll choose all entities in my drawing. And that'll generate then a polyline perimeter around here. So now I have my boundary set. So what I'm going to do is make a surface model of my roadway data. So if I go to my surface menu and say triangulate and contour, I'm going to go ahead and first off specify the name of a triangulation file I want to create. In this case, I'll call this my Highway 52 Iowa, but then I'll change the name here to GPS. And we'll say save. And again, we'll use the inclusion perimeter value that I've established. And I'll go ahead and again, I'm not going to contour this right now. And I do not really need to specify my selection options, especially the coordinate file here, since I have my data on the screen. So I'm just going to go ahead and choose OK. And the inclusion perimeter area, again, I'll choose this boundary. The exclusion, I don't have anything. And the graphical data to triangulate, I'll just say is all. So now we've built that surface model, and if we can take a look at this, we'll go to my view menu, and we'll say 3D views in my surface file. So now I have my Highway 52 Iowa GPS surface model. Oh, and it looks like I made a mistake, so we'll go back and just quickly redo that. So I'm going to go back underneath my surface menu and triangulate and contour. And the mistake that I made was I had a very short interior and exterior triangle length side. So we'll actually widen that out here a little bit. So we'll maybe make this 150 feet for both internal and exterior triangles. And we'll just simply redo the surface model. And we'll correct that one little bit problem. And now that we have that surface model built, I'm going to go again back to my view menu and into my 3D viewer, and we will take a look at the surface file now for the GPS data. And you can see now we have a much better looking surface model of, again, the center line, edge of pavement, and shoulder data that was collected through my field work. So that concludes this topic on how to create surface models from RTK data from a variety of different sources. Thank you for your time.